Delta G plus or minus, and how come? Minus, excellent, yes, because? It's cool. The rule to apply is that when you reverse a reaction, you switch the sign of delta G. You don't change the number value, you switch the sign. So if the reaction is breaking us apart, that's delta G plus. The reverse reaction is putting us together. So that's got to be delta G minus. So there's a bunch of ways to look at it. It's symmetrical. It's sort of they're opposites of each other. Thank you. So making bonds releases energy. Therefore, delta G minus. If you like, and the reason why I do it this way is there are many people that have this misconception that it takes energy to make a bond. And maybe you're picturing sticking pieces together, right? Forcing Lego together to get it to snap together, right? And you need to erase that from your brain, right? That the way to think about it is, I always remember it is breaking a bond, you got to pull it apart. So that means that forming a bond is, they form a bond. They release energy. It's energetically downhill, right? So atoms they're happy to bond, right? There's a lower energy state, right? So for me to always keep it straight, I remembered, you got to go, you got to pull things apart. That's easy to remember. But forming a bond, therefore, is spontaneous. Yes? So if the energy is lost when a bond is made, where does it go? A most excellent question. When I bond, it's a lower energy set. The molecules now have higher energy than this. Lower energy when they're bonded. Where does the energy go? Actually, it turns out once we're bonded, typically a little bit of heat gets given off. That is, these molecules, when we bond, we're slightly more energetic, and that vibration gets translated to heat later on. So that energy is conserved. The potential chemical energy turns into heat energy. Other questions? All right, so that's a biggie. There are my glasses. All right. So that leads to a very important conclusion, another puzzle I want to give you guys, because this is another thing that's not intuitively obvious, but if you figure it out, it makes total sense. So high and low free energy. So what we know is that, let me do this in color. This is breaking bonds. Is delta G plus, moving up the chart. And this is going to be forming bonds. Right? There's a conclusion you can draw from that. Therefore, and this is another one I wanted you to talk to your neighbor about. I got 3 states of a system not bonded at all. So like me and my briefcase here traveling fully separately. So state 1, not bonded at all. State number 2, weakly bonded. So I'm just sort of attached, but not really strongly attached. And then really strongly attached. If you like, not bonded and a single bond and a double bond, right? Or not bonded, a hydrogen bond and a covalent bond. Any way you like. Not bonded, weakly bonded, and strongly bonded. And I want to know on that chart, top to bottom, which one's on the top, the highest energy, medium energy, and lowest energy. So not bonded, weakly bonded, strongly bonded. How do they go in that chart? Based on what we just said up there, it's not obvious, but you can figure it out. So think about it, talk to your neighbor. Those 3 states.